In chemistry, it is common to encounter conversions. Simply put, a conversion is just when you take one unit and change it into another unit. And how we go about it is using what we call equalities, or when two different units are equal to each other. In the bottom of this page, you'll see this is from the textbook, and these are some of the equalities that you might use to help solve a problem. So in a conversion problem, there's a couple things that you want to look for. And first of all, you want to think about, well, what did they give me? So let's read the question. It says, what is the mass in kilograms of an individual who weighs 234 pounds? Okay, so I look at this question, excuse me, and I know that I was given 234 pounds. So I'm given a number in pounds. And it asks me in the first part of the question, what is the mass in kilograms? And so it's asking me, here's kilograms, it's asking me to take the pounds, so 234 pounds, and tell me what number would that be if I had to have kilograms. So generally how I start out the problem is I will write down what I was given. So I'll say 234 and then pounds, which is LB. The L kind of looks like a 1. And that's what I was given. And so now I'm going to multiply it by a conversion factor. Now conversion factors come from equalities like we see in this table 1, 4. So when two things are equal, I can take those two things and write them one on top of the other like a ratio and create a conversion factor. So I look through here, and what I'm trying to find, I have pounds. And I know I want to get rid of pounds, and I'll do that by canceling. So I'll look in the mass, and I see, okay, so here's pounds and here's pounds. Okay, so I have pounds, and now I want to go to kilograms, so I look what they're equal on the other side. Well, look at this first one right here. That one has 1 kilogram equals 2.20 pounds. Let me erase that real quick, because then if you look at the one underneath, even though it has pounds, it goes to grams. So that's going to make my work a little bit more, because if I read the problem, I want to go to kilograms. So we're going to use the equality right here, right there, that 1 kilogram equals 2.20 pounds. Now, in conversions, units, just like numbers, can cancel. So if I have a unit in the numerator and the same unit in the denominator, they'll cancel or go away. So I'm going to take and write the 2.20 pounds on the bottom from right there, and then the 1 kilogram on the top from right there. And now if I'm looking at my units, pounds cancels with pounds, and the only unit I have left is right here, and that's kilograms, and that's what I want my answer to be. So in my calculator, I end up multiplying, get my calculator, 234, and then it would be times this 1 on the top, but, times 1, it would still be 234, so I don't really have to enter that in my calculator. And then when you're below the denominator, I will then divide it by 2.20. And I get the answer, I get the answer 106.3636, and it keeps going till eventually I have a 4. And this now, the units are kilograms. Now another thing we're trying to do is put this in significant figures. So if I go back to what I was given, I see that I was given 1, 2, 3 significant figures. So I'm going to keep 1, 2, 3 significant figures. I'm dropping a 3, so it's less than 5, so we'll keep our last digit the same. So I would report my answer in significant figures as 106 kilograms. So if we go back and read the question, what is the mass in kilograms of an individual who weighs 234 pounds, then the answer to that question, the mass in kilograms, is 106 kilograms. Okay, this problem only uses one conversion factor because and we could get from the unit we were given to the unit we could find. Let's look at another problem. So we read the question first. Remember, we're looking for what's given to us and for what we're looking for. So a patient required 3 pints of blood during surgery. How many liters does this correspond to? So looking at it, I see, okay, 3 pints. I was given, I know the 3 pints. And then it wants to know how much does this correspond to? How much what? How many liters? So I want to find this. So if we think about what we're given, so we're given a unit of pints, right? And then it's asking us to change that into another volume unit of liters. So how we're going to set it up, I always start by writing what I was given. So I want to get out of the units of pints. So I have 3 pints. So now I'm going to go, I need a conversion factor that I have to multiply by so I can cancel pints and change into a new unit. So I go pints, this is a volume, so I go, pints is an English unit, so it's over here, and I see pints right there. Okay, so I see here, it's not going to get me the whole way though, because I see pints on the right hand side, but on the left hand side it's quarts. So I can get out of pints and into quarts. So I would put 2 pints, and that is 1 quart. So if I cancel the pints, now looking at my unit, I would have a unit of quarts. Okay, well that's not where I wanted to end up, right? Because I need to end up in liters, but with the conversion factor I had, that's as far as I could get. So now I'm looking on the other side. So if I look over here, though, look, here's here's quarts and here's quarts. And so I think, okay, well that will either of those get me to where I want to be, and the top one goes to milliliters. So that's not going to help me. But look at this one. It had right here. It has quarts and liters, so those are equal there. So I'm going to use 2 conversion factors. Now, if you prefer, you can get an answer. Like we could have gotten an answer right at that first step. I prefer to write all the conversion factors so I can kind of see where it's going. It's called solving the problem continuously. You don't have to do that if you like to get an answer and then do the second step. So here, I'm going to put the 1.06 quarts on the bottom. And if we were in class, I would ask you why, and hopefully you would be saying to me, because we want the unit to cancel. I don't want quarts, which I have now, but if I put quarts on the bottom, this one will cancel with this one. Now on the other side of the equality was 1 liter, so I write 1 liter. And now look what I've done. It took 2 conversion factors, but now I'm into liters, and that's the unit that I wanted to have. So it took 2 conversion factors. Well, let's do this in our calculator now. So I would start with the 3, and I would say 3, and then we would go times 1, which just gives me 3. You don't have to really do that. Divided by 2. Then I would say times 1 for the next conversion factor, divided by 1.06, and I get 1.41509434. It just keeps going, liters. Now that's what my calculator gives me to think about significant figures. I want to look back at what I was given. So this number has 2 significant figures. So I want to keep 2. So there's 1, 2. I'm going to drop off a 1. So as long as the first number I'm dropping off is less than 5, I'll keep that last digit the same. And so 3 pints would give me 1.4 liters. And so this person who required 3 pints of blood during surgery, if we change that into liters, it would be 1.4 liters. So let's try one more conversion. And this one is what your textbook calls a clinical conversion, partly because the conversion factors that they've written into the problem are given. It's not something we may find on the chart. Some of it's given in the problem. So let's read the problem. We always start by thinking, what are we given? Okay, so it says, if the proper dosage of a drug is 2 milligrams per kilogram. Okay, so there's something we're given. How many grams would a 110-pound individual need? Okay, there's another thing we're given. So 2 things. And what we're trying to find out is how many grams would this person need if the dosage is 2 milligrams per kilogram. Now, this is a clinical conversion, remember? Things that say per or equal to, this is actually a conversion factor. Right? Because what 2 units does this relate to each other? It relates milligrams and kilograms. So it's milligrams of medicine per kilogram of body weight. So the given, what we're starting with, is that we have a 110-pound person. And we want to use that dosage to figure out how many grams of medication this person will need. Well, I notice right away something that's going to puzzle me is the person is in pounds, right? But the weight, the body size is in kilograms. So those 2 things are not going to cancel. So the first thing I'm going to do is I'm going to change the 110 pounds of person into kilograms. So I'm going to go, I know here's the pounds to kilograms right there. I'm going to put the 2.20 pounds in the 1 kilogram. Okay, I'm going to get an answer here. Just, you wouldn't have to. You could do this continuously like I did on the other problem, but I want to talk about it. Okay, so this is this person, 110 divided by 2.20. This is 50 kilograms. 2 significant figures. Okay, so this person weighs 50 kilograms. The dose that they're going to take is 2 milligrams per kilogram. So here's the person. And they are going to take medication that is 2 milligrams per kilogram. Now, why did I write it that way? Not that because that's how it's given to me, but the kilograms here will cancel with the kilograms here. So if I looked at this problem now, I could tell you how many milligrams of medication this person would need. But I don't need milligrams. Looking up here, I have to look carefully. They wanted grams. So let's change grams into milligrams. I know there are 1,000 milligrams in 1 gram. That's the definition of milli. And so I will take 1,000 on the bottom, so my milligrams cancel out, and the 1 gram on the top. So let's see what this equals. You have a 50 kilogram person. They're taking 2 milligrams per kilogram. And then that would give you milligrams. I need to divide that by 1,000. And this person's taking 0.10 grams. I need 2 significant figures. My calculator didn't give me the second 0, but I added it because I need 2 significant figures because I was given 2. So in grams, it would be 1/10 of a gram of medication for this person. Now, conversions are an important part of chemistry, and one of the ways you can get better at it is practicing. I hope this helps you a little bit set up how you might think about how you might set up problems, and always let me know if you need more examples.